Look up at the night sky. It feels permanent, doesn't it? A vast, unchanging canvas filled with the promise of countless galaxies to explore. That feeling is a lie. The truth is, the universe you see is already disappearing. Right now, galaxies are being ripped away from us, pulled into a void we can never reach, receding at speeds faster than light itself. This is the story of how we're losing the cosmos, and why we are completely powerless to stop it. The deception of the night sky: when we look into the darkness, we're not seeing the present. We're looking at a snapshot of the past. The light from Andromeda, our closest galactic neighbor, has been traveling for 2.5 million years to reach your eyes. The stars in our own Milky Way? Their light can be thousands of years old. And the faintest, most distant galaxies we can spot are showing us what they looked like over 13 billion years ago. But this beautiful, star-filled view is a temporary illusion, a cosmic magic trick. Because while all that ancient light was journeying to us, the universe itself was changing in a way that's both profound and irreversible. The fundamental truth is this: the universe is expanding. It isn't that galaxies are just flying through empty space like cannonballs. Instead, the very fabric of spacetime is stretching. The classic way to picture this is to imagine raisins in a loaf of bread dough rising in an oven. As the dough expands, every raisin moves away from every other raisin. From the perspective of any single raisin, all the others seem to be rushing away, and the farther away a raisin is, the faster it appears to go. This is precisely what we see. Back in the 1920s, astronomers like Edwin Hubble discovered that nearly every galaxy is moving away from us. And the farther a galaxy is, the faster it's moving away. This relationship, known as Hubble's law, was the first real proof that our universe isn't static, but a dynamic, growing thing. But hiding inside that simple observation was a terrifying idea, one that wouldn't be fully understood for decades. If everything is moving apart, and that separation keeps getting faster, what happens when space itself starts expanding faster than light can travel through it? The Great Unraveling, Part 1, the invisible acceleration. For most of the 20th century, scientists debated the ultimate fate of the universe. Would the expansion slow down and collapse back in on itself in a big crunch? Or would it just keep expanding forever? The answer, discovered in 1998, was more shocking than either of those options. By studying distant, exploding stars, two separate teams of astronomers discovered that the universe isn't just expanding, the expansion is speeding up. Something is actively pushing everything apart, working against the pull of gravity. We've given this mysterious something a name: dark energy. We don't really know what it is, but we can see what it does everywhere we look. Our best estimates suggest dark energy makes up around 68% of everything in the universe. It seems to be a kind of anti-gravity woven into the vacuum of space, and it's the engine driving our runaway cosmos. This acceleration turns a gentle expansion into an unstoppable force of separation. As space stretches, it actually creates more space, which has its own dark energy, leading to even more stretching. It's a feedback loop that just gets stronger and stronger over time. And it's led to a situation that seems to break the most famous rule in all of physics. The Great Unraveling, Part 2. The faster-than-light problem. Einstein's theory of special relativity is crystal clear: nothing can travel through space faster than the speed of light. That cosmic speed limit is absolute. So how can galaxies be receding from us faster than light? The secret is in that one little word: through. The galaxies themselves aren't breaking the speed limit. Their actual movement in their own little patch of space is pretty slow. The faster-than-light separation is caused by the mind-boggling expansion of all the space between us and them. Think about the raisin bread again. If the dough expands fast enough, two raisins on opposite ends of the loaf can move apart from each other faster than an ant could ever crawl from one to the other. The ant is still moving at its own top speed across the dough's surface, but the dough itself is stretching out from underneath it. It's the same with light in the cosmos. Light from a distant galaxy is always traveling at the speed of light in its local area. But if there's a huge amount of expanding space between that galaxy and us, the total distance can grow faster than the light can cross it. The light becomes a runner on a treadmill that is actively being stretched out. The runner keeps going, but the finish line is being pulled away faster than they can run. This doesn't violate relativity, it's a direct consequence of it in our expanding universe. The Great Unraveling, Part 3, the Cosmic Horizon. This brings us to one of the most chilling ideas in cosmology: the cosmic event horizon. This isn't a physical wall, but a point of no return. It's the boundary in spacetime beyond which events happening right now will never be seen by us. No light, no information, no signal from beyond this line can ever reach Earth. Currently, our best estimates place this horizon at a distance of about 16 to 17 billion light-years. Any galaxy that is currently beyond that distance is, for all intents and purposes, already gone. Now, this can feel like a contradiction, because we can still see galaxies that are much farther away than that. The edge of our observable universe is about 46.5 billion light-years away. But it's not a contradiction. The light we see today from a galaxy that's, say, 30 billion light-years away didn't start its journey from that far. It began its trip billions of years ago when that galaxy was much, much closer to us, and well inside our event horizon. Over the eons, as the light traveled, the space it was crossing expanded, stretching the galaxy's apparent distance to where it is today. But here's the key: for the most distant galaxies we see, the light we're receiving right now is the last we will ever get. While their light was traveling to us, the galaxies themselves were carried past the event horizon by cosmic expansion. We are watching a slow-motion cosmic exodus, as entire island universes sail over an invisible edge, forever lost to our future. This is a heavy topic, and if your brain is feeling a bit stretched, that's a good thing. It means you're grappling with the true, mind-bending scale of the cosmos. If you enjoy these journeys into the biggest questions out there, consider subscribing. We try to make sense of these cosmic mysteries one video at a time, and your support is what allows us to keep going. Now, let's jump into the distant future and see what becomes of our universe. The future, the lonely galaxy. So, what's the final result of all this accelerating expansion? If we fast forward the clock, the picture becomes stark, and incredibly lonely. Over the next 100 billion years or so, every single galaxy that isn't already gravitationally bound to us in our local group will be carried beyond our event horizon. First, we'll watch them fade. Their light will be stretched by the expanding space in a process called redshift. They'll shift from visible light into infrared, then to microwaves, then radio waves, getting fainter and dimmer until their wavelengths are stretched so long they become completely undetectable. One by one, the galaxies will vanish from our sky. Trillions of years from now, future astronomers will have a very different view. Their sky will be almost completely black. The local group of galaxies, our Milky Way, Andromeda, and our other cosmic neighbors, will have long ago merged into one enormous supergalaxy, an island of stars that some call Milkomeda. Beyond it, there will be nothing. Just an endless, featureless void. Those future astronomers would have no way of knowing that other galaxies ever existed. The main lines of observational evidence for the Big Bang, the redshift of distant galaxies and the cosmic microwave background radiation, will be gone. The background radiation, the afterglow of the Big Bang itself, will have been redshifted into oblivion. With no other galaxies to see, the very idea of an expanding universe would be lost. They would likely conclude, quite logically, that their single, static galaxy was the entire universe. Our cosmos, so rich and full of evidence today, will have erased its own history. The what if? Geez, could we ever beat this? Could some future civilization build a warp drive and just outrun the expansion? Science fiction loves concepts like the Alcubierre drive, which would theoretically work by contracting space in front of a ship and expanding it behind. But these ideas are purely speculative. The original model requires exotic matter with negative energy density, something we have no idea how to make, or even if it's physically possible. For all we know, the isolation is final. The story of our disappearing universe is a chilling one. It suggests that we live on a lonely island, and the ocean separating us from all the other islands is growing into an uncrossable chasm. The vast majority of galaxies we can see in our most powerful telescopes are already physically beyond our reach forever. We can see their ancient light, but we can never, ever go there. But this cosmic forecast isn't a reason for despair. It's a reason for perspective. The far future might be one of total isolation, but that just highlights how incredibly privileged our present moment is. We live in a special, fleeting era, a cosmic dawn, where the sky is still filled with the light of a trillion galaxies. We are alive at just the right time to piece together the grand story of our universe, to see where it all came from, and to glimpse its breathtaking scale. The universe isn't just slipping away, it's revealing its ultimate nature to us in the process. And the knowledge of this vast, lonely future makes our ability to witness the cosmos, right here and right now, all the more precious.